You should be all set then forward.
Yeah. Great. Good morning, everybody. My name is Vineeth Ram. I lead the marketing team for the HPC and AI segment at HPE. I'm actually filling in for Bill Manel, our GM. He couldn't be here today. Unfortunately, he had another commitment, but I'm excited to be here, and thank you for the opportunity. Very quickly, the way we think about the data and analytics space inside Hewlett-Packard Enterprise, we really think about this as being part of the digital transformation. So analytics are the key foundation. And we think of a whole range of analytics, right? So whether it be in-memory computing and things you're doing with SAP HANA, whether it's getting the right type of delivery model, consumption model for analytics, or data protection, or simulation modeling and AI, which is really what we want to talk about today. But fundamentally, we are seeing this driving customer business outcomes, whether it be better products and services, whether it be better customer experience or optimizing processes. We're seeing tremendous business value, and I saw the numbers yesterday that I think maybe Stevie mentioned or Earl mentioned about the $551 in revenue for every dollar invested. We're classically seeing that, right? And that's really driving this. But we think about it very holistically. Today, I'll talk a little bit more about the HPC and AI pieces here. We have a pretty comprehensive solution. We focus on providing a breadth of capabilities. So what you're seeing here is our approach to the HPC segment. Clearly, we're thinking about customers where they are, whether they're in academia or industry, which industry vertical, and we try to understand what they're doing. And we really front-end our approach with services. And you might know that of HPE PointNext services. So we've been divesting our services business. A while ago, we did that with the enterprise services, but now we have our technology services rebranded as PointNext, and we have a whole host of advisory, implementation and support services from a HPC perspective as well. And one of the exciting things is the SGI acquisition, which we announced going back to November of last year. Essentially, that acquisition integration is mostly complete. So what you see here is a complete portfolio. If you look at our flagship supercomputer is the HPE SGI 8600, formerly the ISXA, and now it's available with the latest generation of Intel Xeon Scalable processor family. So that's our flagship petaflop scale supercomputer. Then we have the HPE Apollo 6000 Gen 10. This is the most secure industry standard server for HPC and AI. So we rolled this out at the supercomputing at the International Supercomputing Conference going back to Frankfurt in June. And this is really, we've packed in a lot more compute density. We've made a lot of innovation integrating our fabrics, improving performance. We can drive up to 300 teraflops per rack with the 6000 compared to about 600 or so with the 8600. And what we've done here is we've actually embedded the silicon root of trust. So we've embedded security inside the firmware, very unique to what we do at Hewlett-Packard Enterprise. And so this gives you a lot of protection against denial of service attacks, which is where we're finding a lot of issues coming from a security perspective. And we can also track security across the entire supply chain. If there was an event, you could recover much more rapidly. We could be a lot more compliant. So this is a pretty exciting development for us, and now it's commercially available. Then we have the Apollo 2000 as well, which is what we call the bridge to the enterprise, and it's a very versatile platform as well for customers wanting to just chart out to a scale-out architecture. We have our Apollo 6500, which is much more for emerging use cases, as well as for deep learning and AI. I'll talk about that in more detail here. We also have the in-memory computing systems. So the MC990X, that's actually the UV product from SGI, which we had in our portfolio a while before the acquisition, and then the Superdome X as well. So really strong for the in-memory data-intensive compute workloads, specifically for HPC. We have storage as well, so we'll talk a little bit more in detail about storage, but that's an area of focus for us. The HPE Apollo 4520 is a 4U dual server system with a lot of compatibility with software, and then we have the data management framework as well. Another capability which we got from the SGI acquisition. Yesterday I know we talked a little bit about a lot of the storage issues when Earl was showing some challenges, and we think we have some really strong capabilities we'll talk about a little bit more as well. From a fabrics perspective, a whole range of options here. And we also have a partnership with Arista. So for the low latency switches as well for networking, we can provide that from Arista for you. And probably most importantly, the software. All the management capabilities from a software perspective across the entire portfolio, not just for managing the clusters, but also for application development, application acceleration, and a whole lot of exciting capabilities for us. So what we think of as a pretty comprehensive portfolio, whether you're doing high-end supercomputing, whether you're more in a work group type of environment, across the board, we can help you with a platform of hardware, software, services, capabilities that are tailored to meet your needs. And probably most importantly, our partner ecosystem. Intel, Mellanox, NVIDIA are critical to our portfolio today, and we work very closely with them for a variety of customer situations. Very quickly, let's look at this portfolio, some quick examples of how we're delivering value today. Some new examples here. Clearly, we have Pittsburgh Supercomputing Center. I know Nick and team are here. So great partners of ours. They're doing some phenomenal work across a variety of areas, including life sciences and economics. Pittsburgh Supercomputing Center, which is the Bridges cluster, which we had the pleasure of collaborating with the PSC team on. What's unique here is a lot of innovation happening with genomics for research on the wheat and rice genome to make them more drug-resistant, pest-resistant, disease-resistant type of things to make them better. Even things in economics, for example, the optimizing the kidney exchange, right? So whole range of applications, wide-ranging applications with the Bridges cluster. What's unique here is they're using the entire HPE portfolio, starting with the Superdome X for the in-memory computing and all the data-intensive analytics, to our 4-node DL580 ProLiant systems, as well as the Apollo 2000. So a great story to look at the entire portfolio and architecting that cluster, as well as it's based on Intel OmniPath architecture as well to provide the low latency interconnect as well. So great example there. BASF is a much more recent example. So as most of you might know, BASF is one of the largest chemical companies in the world. They've completely gone through digital transformation, transformed digital research, and we've been working very closely with them. And they've built a petaflop scale cluster on the HPE Apollo 6000 Gen 10. So we've actually been working with them. Tremendous benefits that they're driving in the entire chemical process, right? Whether they're going to design and develop plastics or new colors or cosmetics, the entire process of how they're simulating, designing, and automating the research process, synthesizing the results of what they're doing is all now automated through a HPC cluster driven by their HPE Apollo 6000 Gen 10. And this is really giving them a 100-fold reduction in the time taken. So what used to take a year, they can now do it in 10 days in terms of their research capability and what they're driving. So we're expecting some good results here. We expect to see it in the top 500 as well in the near future when it gets operational. And then NCAR, National Center for Atmospheric Research, another strong customer, started with the SGI ICE-XA. It's about a 5.4 petaflop cluster, one of the top systems in the world in terms of performance. Clearly, they're doing a lot of things, whether it be with thunderstorms prediction or earthquake analysis, a whole variety of capabilities. And this is an example of what of our technology with from a supercomputing perspective, what we're delivering for them. And this is based on Mellanox EDR switches as well as a customer. And we recently had a ribbon cutting ceremony for NCAR as well in August. So that was Okay, another exciting announcement that we made in August. You might be familiar with what we did. So HPC is getting to space, and we feel very, very fortunate and excited to be part of this, working jointly with NASA to send a first teraflop scale system to space. So basically putting the first teraflop in space. As most of you might know, when it comes to space, there's a lot of issues. One of the first being environmental issues, cosmic radiations outside the Earth's atmosphere, right, degrade compute performance. So it requires some shielding, which adds weight and increases payload and so on. There's a whole power and cooling issue, getting enough power, able to do the right type of cooling, and then have the performance. So you may be surprised to know that the actual compute systems that have been certified for space are actually many, many generations behind. So there's just been a number of challenges, and we actually set to work with NASA. We've been working with them for a while to actually go and provide some very innovative approach of software-based hardening. So we actually have software that addresses those environmental changes. We have throttling of the system so we can monitor and change the performance based on the environmental characteristics. We've also designed a very ruggedized special enclosure. We have special cooling, which is a combination of air and liquid-based cooling capability. And then we're doing LinPack benchmarks actually running in space. So this system actually went on board the SpaceX rocket to the International Space Station in early August. And right now it's running these benchmarks. And we actually have another system in our facility in Wisconsin. Actually also, it's the same similar system. So we're actually benchmarking against that and tracking the progress. So hopefully we'll have a lot more to talk to you about this when we meet again at Supercomputing Conference later this year. But we're very, very excited that this is kind of taking HPC to the frontier of space now. And this becomes extremely critical because as you get to going to space missions beyond Earth and getting exploring further space travel, what we need is what happens is computing capacity is really required. Latency issues become a big deal and so on. So clearly, huge opportunity for HPC as well. Storage portfolio. So clearly, this is another area of focus for us. We have a broad portfolio here, starting from the Apollo 4520, as I talked about earlier a little bit. We have the data management framework for the software to address a lot of the tiered storage management with an integrated policy-based engine that allows you to do the tiering and solve latency issues as well as manage workflows as well through our system. We have the 4510, which is for object storage. So if you're looking for petabyte scale, lower cost, massively scalable storage, we have the Apollo 4510, and then we have the tape drives as well. So I think Steve's giving me the speed to go faster, so I'll kind of quickly here. This is our deep learning portfolio. So I know there's a lot of focus in this conference on AI. So we believe we have a very uniquely tailored, purpose-built deep learning portfolio across what we do. So whether you're looking at very complex petaflop scale clusters that do combined HPC and AI, which is where the 8600 would fall, or you're looking for very specialized deep learning capability, then that's the Apollo 6500. That's basically, we get 8 GPUs per compute node with that system, tremendous GPU capacity and innovation to get that level of capacity. And that would be our workhorse for training, right? So this is the complex training workloads, which would be the 6500. The Apollo 2000, it could be used as an inference engine or a starting training as well. If you want lower GPU capacity, you can go with that. Then we also have uniquely the edge analytics, right? So our HP Edge line converged system provides a whole host of capabilities for analytics at the edge as well. So if you're doing inference at the edge, as well as we have intelligent data acquisition capabilities for data collection as well. So basically we have the ability to provide an edge to core capability from a deep learning perspective, combined with our software, our storage portfolio, and networking. So clearly we can build a very comprehensive cluster from a deep learning perspective. A great customer example is the Tokyo Institute of Technology, which is what we had collaborate on this with NVIDIA, very closely with them, and TiTech to deliver the largest P100 and SXM2 based cluster in the world with TiTech. And this is also to see the number one top in the Green 500 rating as well. Very, very quickly, we are just a preview of something we're going to be announcing later this month around deep learning. So stay tuned for more, where we're talking about how we want to make it simpler, help customers get started in their journey, help them to scale, and help them to actually optimize. We're working this closely with NVIDIA, and there'll be more to come. But I just wanted to, I know we're running out of time here, so we'll quickly after that. Exascale, very excited to be part of the Path Forward program with the DOE. We have a unique approach to drive an architectural innovation to solve the data movement problem at scale. We're working on all of our memory-driven computing technologies and photonics and other capabilities as well as part of technologies. So really, this is that problem. How do you take something, if we added the top 500 systems, right, we found it can get to 1 exascale, but it consumes 650 megawatts of power, and we probably think about 700,000 square feet, right, 15 football overall field size. And that has tremendous implications on carbon footprint and sustainability and cost. So how do you miniaturize all that? So our approach really is to drive that better scalability, efficiency, performance, and miniaturization by architecture, system design, and working with our partner ecosystem and Gen Z. That's a critical piece of the puzzle. And so finally here, I know I'm out of time here, but very quickly, complex portfolio, comprehensive portfolio, capabilities, the world's most secure industry standard server for HPC, which we announced the 6000, Apollo 6000, as well as a lot of other things. And the key point I want to make is we are very, very committed to the HPC and AI space. As a company, we continue to invest. This is a major priority for us. You see our every earnings announcement we make, it's part of what we talk about as a company. And we look forward to working with everybody here and continuing this journey. And thank you for the opportunity.
Any questions at all? Oh, here we go.
Oh, sure.
There you go.
Yeah, could you just say a thing or two about how the SGI integration has added to the company?
It's been really a extremely positive experience. A number of dimensions clearly on our product technology portfolio. We've gained some incredible skills, and as you saw in our portfolio, the high end of our supercomputing space. Really, if you look at where we were at Hewlett-Packard Enterprise, we were doing a lot of things at the high end of the supercomputing space. We hadn't quite gone to that level. We were more at sort of one level below the high end of supercomputing. SGI really brought all those high-end supercomputing skills to us as a company, and whether it be the expertise, the portfolio, the capabilities. So when you look at what we have, the HPE SGI 8600 portfolio, the entire storage capabilities, skills, the data management framework product line. We also have the Apollo 10 series, which is our more innovative way of driving faster innovation for emerging markets. Those are sort of three big areas. But even things like just beyond the product and technology, if you look at the actual expertise and skills, that's been phenomenal. So the thing that you saw here with NASA, the work that's been going on with NASA, for example, NCAR, the work with them that's been going on, the entire spaceborne supercomputer, all of those activities, right, started at SGI, and they've been extended here. It's really benefiting our exascale initiative as well. It has a tremendous effect on our in-memory computing technology and skills. So later this year, you'll see us come up, make some significant announcements in that area. So across the board, whether it's product, technology, expertise, we've integrated manufacturing capabilities. So in Chippewa Falls, Wisconsin, what we have, the capabilities there, which are leading world-class capabilities. So people, expertise, technology, product. And it's been, fortunately, very complementary, bringing much more on the supercomputing focus for us, and to build out a very comprehensive portfolio. And last but not least is services, right? Services is very big. And the software portfolio as well. So a lot of capabilities in software for workload acceleration for supercomputing. Some of those things that we've been able to do in the MPI area has been integrated into our portfolio as well. So now we are one. So that's just from a benefit perspective. The integration is pretty much complete from a product, technology, engineering, supply chain, manufacturing perspective. Our sales teams will be integrated completely within the next 60 days when our fiscal year ends. But it's been and the cultures have been very similar, and the teams have been well integrated across the board.
So one quick question, 2 parts. What are you calling the spaceborne system? And I'm hoping it's HAL something. The second part is, what are the experimental goals with this? Are you looking at the benefits of a standalone supercomputer? Because I'm imagining that there are lessons to be learned in bifurcated, stressed networks, and from the military perspective, what it's able to do on itself. What are your objectives for this experiment?
first question is it's not really a commercial product, right? So we've not really thought about what we would do there. So that's just the name for now is what we have. Really, I think the implications are several-fold. We're trying to understand what this means. One of the things examples that we know of now is when you start going to missions that are far out in space. So for example, the mission to Mars. I think there's some calculation to say for a single for data to go back and forth, right? So if you were to have data centers on Earth, and then you would try to get some information back, it takes about 20 minutes each way. So you'd take 40 minutes for data to travel. So really, that latency would not be practical for us for doing things. And then as you add more and more tests and more things that you have on board, then you need more and more capacity, more and more processing capability. Eventually, this will allow us to do a lot more experimentation, a lot more things, and get much more information and data at that level from here. So I'm expecting it's going to have a lot of far-reaching implications, especially given that what we were quite surprised is to see that the space-approved kind of technology has been very dated, right? It hasn't been, it's many generations behind. So I think the potential of what you could do with computing is probably a lot once we can get this to go through, because the fundamental technology you're talking about, like environmental shielding, right? That could be applied across the board in many of the applications that you talked about now. Innovation on the power and cooling type of things, et cetera. And what we are doing is also software-based throttling, which is what we want to be able to perfect, which will now start to make sure that we can actually prevent any degradation in performance by pure software. So we can shrink the payload, shrink the size, weight, et cetera, and make it much more ruggedized with software. And all of this, by the way, I forgot to mention, is all based on commercial off-the-shelf server technology. So the server itself is commercial off-the-shelf technology. All the innovations around it, in the enclosure, the software, the design around it, and I think the applications are probably numerous. I don't have much more than that, but I can get you more information from our teams, and I'm sure NASA has got a lot more information too we can get you. Okay.
Great. Well, thank you very much.
Thank you.